Hi, my name is Dylan, and I'll be going over the last part of chapter 5, 5.7. In this video, we'll be learning something called inequalities. We'll learn how to graph them, some properties of them, and how to solve them. So, inequality symbols. The first symbol you should know is this little like triangle arrow thing that's pointed to the right. And this means that something is greater than, such as 5 is greater than 2. It's really not that difficult. It's just like, is this number bigger than the other one? If we turn this number the other way, it means that the number is less than something. So, such as 3 is less than 4. Now the first symbol, greater than, if you add a little line under it, it means that this symbol is greater than or equal to. Like 4 is greater than or equal to because 4 is the same as 4, or 5 is greater than or equal to 4 because 5 is bigger than 4. Flip it the other way, it means that less than or equal to, so it's like 3 is less than or equal to 3 because 3 is equal to 3, or 4 is less than or equal to 10. So the first thing we should know is how to graph an inequality. So we want to graph, in this first problem, we want to graph numbers greater than x on a number line. Okay, so let's first start doing this. So when you do this, we want to make sure we mark all of the numbers that are greater than x on a number line. So first we draw a circle and then we draw an arrow. And what this means is we've highlighted the solution set of all numbers greater than x, 2. The reason why we put an open circle over 2 is because 2 is not greater than 2. 2 is not bigger than itself. So we don't include 2 in the solution set. Therefore, that's why the circle has to be open. Now, if this problem were to say x is less than 2, we would draw the arrow the other way because we want to show all the numbers that are smaller than 2. However, the circle still remains open because 2 is not smaller than itself. Now we want to graph x is less than or equal to 0 number line. So we want to show all of the numbers that are smaller than 0 or equal to it. So in this case, we would draw a circle, but we'd fill it in because 0 is equal to 0. Or it's less than it, because it's equal to itself, we can include 0 in the solution set. We draw an arrow to show all of these numbers are either smaller than or equal to 0. If this were flipped the other way, like x is greater than or equal to 0, we would show the arrow the other way, but still with the closed circle. Some inequality properties you should know. The addition property of inequality states that for any inequality, we can add or subtract a number to both sides of the equation, and the equation will still be true. This is exactly the same as the addition property of equality. So for example, 5 is less than 6. We can turn this into 5 plus 3 is less than 6 plus 3, or 8, and this turns into 8 is less than 9, which is still true. Therefore, if A is less than B, then A plus C is less than B plus C, and this is also true for other types of inequalities, like for example, greater than or equal to, less than or equal to, you know what I mean. So the multiplication property states that for any inequality, we can multiply or divide a number to both sides of the equation, and the equation will still be true. However, if the number multiplied or divided is negative, then we have to reverse the sign of the direction of the inequality. Let's take this first example. 7 is less than 9. If we multiply both numbers by 2, we get that 7 times 2 is less than 9 times 2, or 14 is less than 18, which is still true. However, if 7 is less than 9, if we multiply both numbers by negative 1, we get that negative 7 is smaller than negative 9, which is not true, as negative 9 is smaller than negative 7. This is why we have to reverse the inequality. So when you multiply 7 and 9 both by negative 1, we have to turn the less than into a greater than, and this turns into negative 7 is greater than negative 9, which is true. We can solve linear inequalities just like we can solve regular equations. However, unlike equations, linear inequalities have an infinite amount of possible solutions regardless of how big the solution interval is. Let's solve this equation. So we can solve it by doing the same thing as solving a regular equation. So let's subtract 8 from both sides. Immediately, we get 2x is less than 5x plus 1. Now we can subtract 5x from both sides, and we get a negative 3x is less than 1. we divide both sides by -3, and we have to reverse the sign, so x is greater than -1/3. And so this is our answer. Now we can also write this in a different form called a solution interval, and we can showcase this by writing -1/3, comma, infinity. What this means is that the solutions are in this interval. The smallest number can be is -1/3, and the biggest it can be is infinity. And the reason why we put curved parentheses is because x cannot equal -1/3, and since there's no number actually called infinity, there also has to be another curved parentheses on the side. So now let's solve this one. We subtract 4 immediately. So we get 9x is equal to less than or equal to 11x plus 4. So we subtract 11x from both sides, so -2x is less than or equal to 4. We have to divide both sides by -2. So we get x is greater than or equal to -2 because we have to flip the inequality. And we can show this by saying the solutions can be, so this is your answer, but you can also write it in this form, -2 comma infinity again. This time, the infinity always has a curved parentheses. In this case, the -2 has like a bracket because x can equal -2, as x only has to be greater than or equal to -2. So -2 is also a solution for this inequality. So three-part inequalities really aren't that different than normal inequalities, other than the fact that they narrow down the solution interval. However, we can perform operations onto the equations. When we do that, we have to perform it on every part of the inequality. So 5 is less than -2x plus 1, which in turn is less than 9. So this means that this little equation right here is bigger than 5 but smaller than 9. So we can first solve this by subtracting 1. But when we subtract 1, we subtract 1 from everything. So -1, -1, -1. So 4 is smaller than -2x, which is smaller than 8. Next logical thing is divide by -2. But when we do this, we divide everything by -2. So we divide by -2, divide by -2, divide by -2. The trickiest thing is to remember that when we divide by a negative number, we have to flip the sign. So -2 is greater than x, which is greater than -4. So the answer is x is smaller than -2, which is in turn bigger than -4, and this is your answer. You can also write this in solution form interval, which means it goes from -2 to -2 to -4 to -2. Sorry, and again, open curved parentheses because neither of these numbers are actually solutions, but as long as x is in between these two numbers, it is a solution. That's it for this video. Thank you for watching, and I hope you learned something about this video.